everyone. I am Mukesh and this is the topic for the RM coursework. Move towards
Information and communication services are recognized world over as an important tool for the socio-economic development of a nation. It is one of the prime support services essential for rapid growth and modernization of various sectors of the economy. Information and communication technology usage has grown at an almost exponential rate worldwide with an estimated 6 billion users in 2007. On the last count, the number of mobile subscribers in India is almost 950 million and growing. The growth story can also be illustrated by the fact that 50,000 towers in 2007, India now has 4 lakh towers across the country. According to TRAI, India has about 70% telecom towers are in rural areas. Presently, 40% power requirement are met by electrical grid and more than 60% by diesel generators. The increasing in the number of subscribers has led to greater energy consumption. One analysis shows that in financial year 2005-06 and financial year 2010-11, the energy consumed by the mobile telecom sector stood at 39 picojoule to 163 petajoule respectively. In 2011, total consumption is 3.2 billion liters of diesel and 16 million tons of carbon dioxide are produced. Indian telecom industry invests 8,500 crores every year on diesel and second largest diesel consumer after Indian Railway. Actually, these numbers indicates there is an urgent need of new approaches to reduce the energy consumption and corresponding carbon dioxide emission of the growing Indian mobile telecom industry. So from the operator's perspective, energy efficiency not only has a great ecological benefit and represents social responsibility in fighting climate change, but also has significant economic benefits.
Actually, previous research is different from the current research because previous research is based on system efficiency. System efficiency is a widely used performance indicator for the design of wireless communication systems. System efficiency basically oriented systems are designed to maximize system efficiency under peak or average power constraints, which may lead to transmitting with the maximum allowed power for a long period and thus deviates from the energy efficient design. This is the well-known formula for the channel capacity, which is given by the channel. According to this formula, if we want to increase the channel capacity, then we have to increase the bandwidth efficiency. These are the different topics by which we can achieve our goal. First one is the green cellular base station, then energy efficient mobile terminals, green ad hoc and sensor networks, energy efficient signal processing techniques for the wireless communication, green cognitive radio, resource efficient cross layer, opportunistic spectrum, reticle and distributed techniques, electromagnetic pollution mitigation. Actually, I am interested in energy efficient signal processing techniques for the wireless communication. Orthogonal frequency division multiplexing is an important wideband transmission technique for wireless communication systems. Compared with the other competing wideband transmission technology, that means multi-carrier CDMA and OFDM system can very efficiently reduce ISI, inter-symbol interference problem. OFDM is a promising candidate for achieving high data rates. These are the different channel models which are used for the wireless communication. Relay fading, Gaussian fading, Nagami M, Nagami N and Nagami Q fading channel. I am interested in Nagami N fading channel. This is a distribution for Nagami N. In this distribution, N is the Nagami N fading parameter which ranges from 0 to infinite, and I0 is the zeroth order modified Bessel function of the first kind. First objective is to develop the characteristic function of sum of Nakagami N random phase vectors in a closed form by using an integral expression. Second, to derive the PDF of sum of Nakagami N random phase vectors in an integral form by using characteristic function approach. Third one is to evaluate the analytical expression for error rates of OFDM system over frequency selective Nakagami and fading channel for BPSK and QPSK modulation scheme, and finally to analyze the graphical results for analytical expressions obtained for Nakagami and fading channels. These are the methodology for our research work. First one, we calculate the characteristic function. Then using characteristic function, we derive PDF. Then choose result modulation technique. In our research work, we choose BPSK and QPSK modulation technique. Then derive error rate expressions, and finally analyze the analytical results. This is the derived PDF for Nakagami and fading channel for the single random variable. This is the for two random variable. Using this PDF, we derive error rate expression for the single variable and with the two random variable for the Nakagami and fading channels. The graph which is plotted in MATLAB. In this graph, you can see when we increase the fading parameter, that means n, the performance is increases. We plot the graph for the n equal to 0, 1, 3, 4 and 5. Second one for the two random variable. In this graph, you can see there is a threshold point which is 1.4. After that, performance is degraded, not increases. And finally, this is for the QPSK system. In this graph also, after 1.4, performance degrades. Now, finally, conclusion. Integral PDF has been derived using characteristic function approach. This PDF further utilized for evaluating the closed form expression for average error rate performance of OFDM system over Nakagami and fading channel with the fading parameters. And finally, it has been concluded that depending on the number of channel taps, larger Nakagami and fading parameters do not necessarily give smaller error rates.